So let's see. We have a few questions. A few different sources here. See if they line up. Oh, beautiful. I love it. Sorry. Oh, I got other stuff here too, real quick. Selena. David. Diana. Vu. I think that's this chair that I'm using. Got. Okay. Should catch me up here. Oh yeah. All right, so the first thing I got is 14:3, number 40. Five weeks went by. You know that? Holy shit. Feels like yesterday I was talking about the syllabus. And Thursday's the fun. Holy shit. Number 40 and 14:3 says, graft by hand. And they don't really specify a way to do it, so if you're not sure what the graph of something looks like, what do you do? Yeah, make an XY table. Now, you should know roughly what log looks like. A to the x looks like this. Log base A of x looks like, and we just did it earlier, right? Looks like that, right? Didn't actually hit that, but oh. You with me? So you know the basic shape of it, so you just need a few points to fill in that curve. And what are some smart points to pick?
1, 0.
Who to what?
0, 1, 8.
0 is bad. Because what's log raised 7 to 0? What do you raise 7 to make it 0? You can't. 7 to the negative 10 trillion is not 0, right? So you just can't make it 0. So a smart thing, yeah. So 1 is smart. Something less than 1 is also smart. 1 over 7. And then another smart thing. 7. Sweet. And those correlate to what power do I need on 7 to make it 1/7? Negative 1. What power do you need on 7 to make it 1? 0. What power do you need on 7 to make it 7? 1. Plot those, fill in the shape, you're done. So where's the asymptote for a log if it hasn't been shifted around? Yeah, the y-axis, which is also known as Fred. No, it's also known. The x-axis is y equals 0. The y-axis is x equals 0. That's crazy. So the asymptote for this is y equals 0, and the asymptote for this is x equals 0, which makes sense because what does an inverse do? Switches the x and y. Cool. Welcome back after a very long weekend. Bam, we get back into it. All right. Yeah, you guys can plot that. That should be good, right? Yep. 45. 45, same thing. 45 is easier. It's kind of weird to graph a log because we're not used to working with logs. But it'd be so much easier to graph 7 to the x first and then graph the inverse. And that's what 45 says. Graph 3 to the x. You should not even need a table to do this. What are the 3 kind of points I can use? Negative 1 goes to 1/3. 0 goes to 1. And 1 goes to 3. All right, so then this looks like this. And how do I plot the inverse? Do I have to make a table? No. That goes to the point negative 1 1/3. So my inverse is going to go through the point then 1/3 negative 1. and so forth. I mean, that one's not so, and then you'll get the shape. So it's actually easier to graph log if I can graph the exponential first and then just treat it as an inverse, which is what it is. We're just not used to thinking about what to plug in here to make sense. I would never plug a 3 in there. Good God, what's log base 7 of 3? I don't freaking know. Right. Okay. 105. What's the first step in a simple... And I don't say that to make you feel bad. This is a simple log equation just because I will very soon make them uglier, right? So in terms of that, that's a simple one. And what do you always want to do when you try to solve log equations? Who remembers? We've done this before. Rewrite it. Rewrite it as x to the 1/2 equals 9. And of course, we know the 1/2 power is a square root. How do you solve that? And you guys are making me tired. I can't look at you. Everybody. I was over there, you're young. I was over there. I was like, shit, where can I look?
Square both sides.
Square both sides. And you're done. I mean, so if you have a single logarithm in an equation, so your equation is log equals number, easy. You rewrite it if you can't just do it directly. If the x is stuck in here somewhere, you just rewrite it.
Whenever it's like log 4 to the x, and then equals whatever, how do you solve for the exponent?
What do you mean? How do I rewrite it?
So it would be 4 to the second equals x.
Done, basically. 16. Yeah, done. Do you see what I mean? So when your x is stuck in here in the log somewhere in an equation, you just rewrite it. You can either solve it very quickly or it's already done on the next step, right? Let that be easy because we're going to make it a little bit harder today. So this is that skill. This is based on that skill of rewriting from exponential to logarithmic or the other way, from logarithmic to exponential. And this should be the simpler way. The base to the power equals the thing. Bam, bam. Maybe. Anything else from 14.3? Before I go to 14.4? 14.3? Did you guys find time to do homework? Or is it going really well? Maybe I'll be an optimistic fool.
I have a question.
14.4 was like
Yeah.
I like it. Don't look concerned, but that's true. That's the way it should be. I like that. You're like, I missed something. It was too easy.
For number 55, it's 10 to the negative.
Blah, 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 yep.
Yeah, how do you? I'm just having trouble.
It's
Oh.
calculator.
All right, let me pull this dude up. I'll show you a couple things once this guy's awake, including that. So we'll let this guy wake up and I'll come back to that. Anything else from 14.3? Oh yeah, today's the first day to register for classes if you are in the group that can do that.
Next week.
If you're not, it might be a week or two away for you. Just pray and do whatever ritual you can. All right, so moving into 14.4. I'll come back to that as soon as he wakes up. Or she, I can't tell. 14.4, the question I got is 45. And that's the one where you want to break up a single log using the properties. I gave that sheet out last time, right? The one with the properties on it?
Yeah.
So if you didn't get that, I'll give it to you here in a little bit because we didn't do any of the problems yet. So as soon as I'm done answering these homework questions, we'll probably do that. So 45's got this disgusting looking big cube root. What should be your first thing you do?
What is the root? The third power. Or like 1/3. Good. That's 1/3 up there.
Okay, cool.
Third power.
Yeah.
And times, and you do the things.
So how can I rewrite each of those inside? X to the 6 becomes what?
6 log A.
No, I can't do anything yet.
Okay, just
X
squared.
Good. All right. So I'm not doing any properties of logs because I don't have any property of log that tells me what log of cube root of stuff is. You with me? I know what the log of something to the cube root is. I can to the 1/3 power. I can do that. I've got too much shit all under one thing. I got to distribute. I got to kind of like break them up a little bit. So this would be 6/3. That'll be x squared. Y to the 3/3 is first power. A to the 2/3. Z to the 7/3. All right, let me stop there for a second. Now I've got individual stuff that are multiplying or dividing. At the end, which term should be negative? The logs that have what in it?
They're in the bottom.
Yeah, so the log that has the A in it and the log that has the Z in it, they should end up negative at the end because those are the two that are on the bottom. And that makes it so much easier. I can just do it with, these are multiplying, but so are these, and that's what throws people off. But they're both multiplying on the bottom. So overall, they're both dividing. So it'll be positive log A x squared plus positive log A y. So when I hit this guy, I got to write minus log A. You can do it, Jeff. Too many A's. And then, what about for this guy? Minus log A z to the 7/3. Yummy.
And now you move the powers, right?
Yeah, I can move the powers down. Of course, what can I do with this guy? This is the only guy that really plays nicely with his stuff. The 2 can come down. That one just becomes negative 2/3. Kick ass. This guy's got no power, right? So we're like, we can relate to you, dude.
That one just got some things.
Yeah, this one just becomes
Negative 2/3.
2/3, yeah. Become a 3. And then that last one, 7/3 comes down. Holy shazma. But the most immediate concern was this, and since logs are based on powers, you immediately write any roots as powers. That makes sense. Logs are based on powers. They're not based on roots directly. So I want to make them all powers, and then it's that easy. Let it be that easy. All right, anything else from 14.4? Yes?
60.
Oh, this is an interesting little section because they tell you what log B of 3 and log B of 5 is. On 60, you don't really care. $60 is log B square root of B, this guy. And what was the thing I just said about roots? Yeah, rewrite it. And this becomes that silly kind of thing. What do you raise B to get B to the 1/2?
So the answer is just 1/2.
Beautiful. So that's the one out of that section that doesn't matter their definitions of log base B of 3. And it's just 1/2 no matter what.
66 was like that also. So I was like, I don't know where those numbers are supposed to
Yep,
be.
same thing. Cool. I like it. 54. Oh, yeah, that's a good one.
Do a factor here, then cancel electron.
Eventually. What was the very first thing I do is log of something minus log of something.
It's different.
They have the same base, so I can rewrite it as what now? The mistake I get is this. That is very, very wrong. That's the magic shit. And this is where people don't understand. They say, well, that's what you did. No, it ain't. this is subtracting them, and you're saying subtraction becomes multiplication. The subtraction sign just becomes really big, and then you put it there. A subtraction cannot become division. It can't, and that's not what the property says. It says the difference of two logs is the log of the arguments. Yeah, the log of the quotient. I'm going to put it that way. So the difference of two logs is really, remember, log properties are the same as power properties. When you subtract two powers, when you were dividing the things. And now you can do like you're saying, Frank.
Do x plus 5.
Do you see how this inside is its own little problem? You can't do shit with this. Log base A, I don't know what the hell it is. But inside, I can simplify that. On the top, I can take out 2. And on the bottom, I can...
X plus 5.
Yeah, and then you can cancel the... Wow. Is that cool? Uh-oh. That's an interesting noise. All right. Anything else from 14.4? I think that's as far as we made it last time. So let's do this. Who needs this handout from last time, with the properties on it? Anybody else need that? If you missed last class, you probably want to go see the video. I'm not going to reprove these things. Yes. But you see how we know logs are powers, right? If I say, what's log base 3 of 9? What's log base 3 of 9? What's log base 3 of 9? 2. Why?
3 times 3 is...
Yeah, 2 is the power that 3 needs to become 9. So the answer to a log is a power. So logs have all the same properties powers do, because that's what they freaking are. So the product rule, the log of a product, when you multiply things with like bases, you add the powers. That's what the product rule says. So take a quick minute and try to do those problems. 1, 2, 1, 2, 3, 1, 2, 3. Does everybody still have this from last time? Anybody need another copy? I have some extras.
Oh, there it is.
Sure. Oh, here we go. Sophia, did you ask that question earlier? This guy finally woke up, so we'll do that here in a minute. I'm going to start to attack these. This is basically you get it or you don't. Right, so these should be like bam, 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 if you get it. So this first couple are all about the product rule. What can I do with this first guy?
Log 3 of 3 plus log.
Yeah, log 3 of 3 plus log 3 of x. 1 plus log 3 of x. Now look how that's very similar to if I had like the square root of 9x. What would I do with this?
3 times 3.
Square root of 9 times the square root of x, right? I do the part that I can and I don't do the part that I can. So the square root of 9 is 3 and this other x stays in the square root. I did the part that I could and the other one has to stay in because I don't know what the hell it is. So again, logs are not the same as radicals, but they are very closely related because radicals are the opposite of constant powers. Like square root is the opposite of squared, whereas logarithm is the opposite of any power. I don't know if you understand what I'm saying. It's an x power, right? It's not just the square root, it's the x root. In this case, the base is 3. It's kind of weird, but so they should kind of be similar, but they're not the same thing. This guy's nice. What can you do here?
Log 3 times 4 is 12.
Yeah, the opposite, right? It's the opposite of this. Put them back together. Log base 12 of 12, which is 1. Kick ass. Kick ass. All right, what about this guy? Same idea, right? Same idea as the first one. Be log base 3 of 3 minus. So it's 1 minus log base 3 of 5, because I don't know what log base 3 of 5 is. I could guess 1.2. I don't know if that's right. What about number 2? It's like that one in reverse again, right? Log base 5 of 75 over 3 is log base 5 of 25, which is 2. It takes the power of 2 on 5 to make 25. The power is 2. Now, this one's kind of nifty. I mean, did anybody realize? Well, let's do it this way first.
Log 1.
What's this mean? Log, and there's no base. It means base 10, because that's the one we use the most, for some reason. So I could say log of 1 minus log 10. What's log 1? 0. Log of anything of 1 is 0, because it takes a 0 power to make something become 1. And what's log 10? 1, because it takes 1/10, so negative 1. But a much more direct route, what do you do to 10 to make it become 1/10? I raise it to the, I don't flip it, I raise it to the negative 1 power. So this directly, I can just see it's negative 1, right? It's log base 10. What do I do to 10 to make it 1/10? Raise it to the negative 1 power. So either way you do it, it comes out the same. Thank God. That's the way math is supposed to be for the most part. Okay, cool. There is fuzzy math and fuzzy logic and chaotic math. Watch the first Jurassic Park and you have the whole Jeff Goldblum thing. Right, you remember that? Drop the water on your elbow. All right, Chuck. All right, so what happens here? Yeah, the 2 comes down. I can't do anything else because 3 and A are not, as far as I know, related. What do I do on this second one? 1/2. Yeah, I got to rewrite this as x to the 1/2, and then this 1/2 can come down. Stop there for a second. Okay. And then this one, you actually don't have to do as much as you might have. Careful. If you rewrote square root of r as r to the 1/2, it better remain r to the 1/2. But you don't have to do that. What happens to whatever the hell this is? It can come down. So it'll be square root of r log base w of e. Or r to the 1/2 log base w of e. This better still be a square root of r. Whatever the hell is up in the power of the argument can just come straight down. Why don't I have to rewrite that root? Because the log is not acting on it. It's jumping out front. Maybe. All right, cool. So that's section 14.4. Let's do this real quick. There's two ways to do this. The most direct way is just say 10 to the, and then whatever the heck it was, negative 2.9523. I don't even remember what it was. Blah, blah, blah. Is that cool? And then you also have, if you want to, the log is log base 10. What's that the inverse of? What's log base 10 of x the inverse of? 10 to the power of x. Cool, right? 2 to the x is the inverse of log base 2 of x. Right? That's the first thing we did when we talk about logs, is we drew the picture before we even knew what the hell it was. It was the inverse of an exponential. So if you look at log, what's right above log? Everyone knows it's log. 10 to the x. Cool. So if I just did second log 10 to the negative 2.952, so just to make it the same. Well, I don't even know what the real number was on my problem. There, it's the same number. It's amazing. But I mean, how big of a shortcut was that? Not. so it's nothing amazing. All right, but they do like to put their inverse functions on the same button as their functions. That kind of makes sense. All right, how's that? Is that cool? There was something else I was going to show you, and I completely forgot. Just do that. No. Oh, I'll think about it. Okay. So anything else about 14.4 before we get into 14.5? Okay, let's get into 14.5. The only thing 14.5, we already talked about the change of base formula. The only thing I still have to do is talk about E. So real quick, remind me, what's pi, for example? What's pi? The reason I wore this shirt. So you can tell me approximately what it is. What's the idea of pi? Why did math people give that number its own symbol? Why didn't we give 7.0349999432969? Why didn't we give that a symbol? I don't know. Why did we give pi a symbol? Does anybody know where pi comes from? Besides the other? You guys know? What's the formula for circumference? Who remembers? 2 pi r, otherwise known as pi. What's twice the radius? The whole diameter. Kick ass. So the circumference of a circle is pi d, or 2 pi r, because d is 2r. The diameter is twice the radius. All right, maybe. You guys look semi sort of interested. Good. All right. Now, if I do any circle I want, so I can make this out of string, for example. I can make a string circle. I can measure its diameter, and then if I lay the string out and measure the string, what did I just do? If I measure the string, I got the what? Circumference. So if I do that for any size circle, if I take the circumference of a circle divided by the diameter. So if I take this circle, if I take that circle, if I take the earth and cut it in half and do it, it's almost a circle, right? Take the sun, do it, right? All right, you kind of with me. No matter how big or small the circle is, this ratio always came out to be the same freaking thing. It freaked people out. Why wouldn't it freak people out? If I make a bigger circle, I would expect it to be different. But the ratio stayed the same freaking number. And that's why, a long time ago, they gave it the symbol pi. Because it was a special thing. Nowadays, people think they should have called 2 pi. 6.28 blah blah should have been given a symbol, but it's too late. It's too late. Then the circumference formula would have been pi r, if pi would have been 12. Let's not go there, Jeff. Let's just, we'll be all right. I don't know. Do you guys know the history of pi, or do you just know pi is there? Unfortunately, we're talking about the mathematical pi, right? Sorry. Now we're all like, where can it go? Pi, apple pie. What's an apple pie? All right. All right. So that's pi. Let's talk about e. So I kind of showed you this picture. If I graph just the positive part of 1 over x, and why does it make sense that this is, and it's got another part of it, I don't care about that. So f of 1 should be 1. F of 1/2, what's 1 over 1/2? What's 1 divided by 1/2? 2. 1 divided by 1/10? 10. 1 divided by 1/100th? 100. See how that makes sense? That that's just going to grow really fast, really crazy. And and if I go the other way, it's going to do the other way. So at 10, it's going to be 1/10. At 100, it's going to be 1/100th. So that's why that makes sense. Are you guys kind of with me? I like this definition better than the standard one given, but I'll show you that one too. So here's the neat thing. If I find the area, this is what calculus will do for you. It can find the area. Why can't we find that area? Because it's a freaky shape. What the hell? It's not a straight line. I don't know what. It's not even a trapezoid or anything. It's a curvy dude. I don't know how to find that freaking area, but calculus will eat this up, spit it out. The funky thing is, the number e, you put it about where it is, 2.7128, blah, blah, that's as far as I decided to remember. If I go up to e, this area is exactly 1. The area is exactly 1. So if you just go from 1 to that number e, the area between there is exactly 1. That's interesting. That's the definition you normally don't see. Now, I need your help for the definition you normally see. You ready? You guys got a calculator? You gonna help me? All right, people are moving. So if I let x get really big, and normally the way we talk about that is x goes to infinity. If I let x get really, really big, this will become e. And I want you to see, what happens to this when x gets really, really big? What happens to this? Gets really, really small. In fact, when x gets to infinity, that's going to become... No. 1 divided by tremendously big is the smallest number, is 0. So this is going to 0. So it looks like it's going to be 1 to a power. It looks like it should come out to be 1, right? Stay with me. Come on, come on. We can do this. If that piece is going to 0, what's left? 1. And 1 to any power is freaking 1. Is the inside ever actually 1, though? What's the only time this becomes 0? When I get to infinity. Can you get to infinity? No, you can try, right? You just walk. We're on the earth, unfortunately, you just won't really, you'll come back to where you were. So this never gets to 1. So if you do me this favor, let's try if x was 10,000. Just do that by itself. I mean, it's nothing amazing. You just put the 1 in the right place. But if you do that in the calculator, what do you get?
1.0001.
Yeah, 1.0001. Tenths, hundredths, thousandths, 10,000ths place. Are you with me? But now I'm going to raise that to the what power to do this? 10,000ths power. So take that number you got now and raise it to the 10,000ths power. Holy shit. So I want you to really understand, that's stupid close to 1. As far as a human being is concerned, I would say that's 1. If I said, how much does this cost? And you said, $1.0001. And looking at you like, it's $1 then. What the hell's your problem? I only have a tenth of a penny here. So that's like 1. But it's not 1. Right? As far as math is concerned, this is way bigger than 1. This is huge compared to 1. And when I raise it to the 10,000th power, it's going to kind of build on itself. And that's already close to E. This is the 2.71. Oh, I got close. I put an extra 2 in there. So if you do this again, 1.00001 to the 100,000ths, that's going to be even closer to the right value. Maybe I'm right. Oh, I should get there quicker. Oh.
So just gotta keep going forever.
Yes, so if I keep putting larger and larger things here and there, the inside's going to get smaller and smaller, the power's going to get bigger and bigger, and they kind of agree on the number that we call E. So where's your E button? You guys see your E button?
On top of the react.
Good, it's on top of this weird ass ln. So if I do e to the first, it'll tell me what e is. Well, there's your 2, Jeff. After 2.71828, 2 basically goes forever. All right, you guys doing okay? So whenever we give a number a symbol name, a symbol to represent it, that normally means that 2 things actually. It's very interesting where it comes from, but it's also useful in formulas. I don't want to write, that would take me forever. I can just write pi that represents this infinitely long decimal number. You with me? E comes up in a lot of places. Holy shit, if you take any biology, any chemistry, you're going to see E that represents population growth. So some rabbits in a room, give them some food, and see how quickly the population grows in that room. You with me? Make sure the food part's important. Right? Don't come back in a few weeks and oh, the food, I forgot. That's so horrible. Horrible. Sorry, I got this cannibal bunny thing in my head now. That was really horrible. It's too bad. You guys will be all right. So, what we've got now is we've got this base, E. And what is E in between? What 2 nice numbers is E in between? 2 and 3. It's crazy. So if I graphed, real quick, you don't have to do this, but if I graph 2 to the x, so it looks like that. There's 2 to the x. And then I graph 3 to the x. And the only difference there will be this is a little bit taller and this is a little bit shorter. E to the x is in between the 2 of them, right? It's closer to 3 because it's closer to 3. You guys kind of with me? So the nifty thing about E, it models population growth really well. It allows us to put the percentage growth here as a coefficient of x. It does a lot of stuff for us that helps with population growth. Or if I made it negative, it would be radioactive decay, for example. Right? So how long until you can go to Chernobyl? Although they made this stupid movie that thankfully I didn't watch. I don't think I missed anything. How long until it's really not radioactive anymore? You can use this kind of formula to tell and when it gets to safe levels. Right? Be able to plant anything there for a long time. All right, cool. That's all section 14.5. The change of base formula and the idea of E. Now, what's the inverse of E? I'm only going to write, now be careful, not the reciprocal. 2 totally different ideas here, right? The reciprocal is not the inverse. The inverse is the function that does the opposite. What's the inverse of 2 to the x? Log base. The inverse of 2 to the x. Log base 2 of x. Incredible. What's the inverse of 7 to the x? Log base 7 of x. We're going to do it again even. What's the inverse of 11 to the x? Log base 11 of x. Of course it is. That's where we started with logs. We built them as an inverse. And then we gave it its own name. We thought, oh, that'd be nice. Give it its own name.
Log base E of x.
Yes, it's the only time I'm going to write this. It kind of hurts to write this. Yeah, log base E, we immediately, we just give it the name natural log of x. Since e to the x models natural growth patterns, the log we decided to call it natural. There's other reasons too. That explains why your e to the x is on top of your ln button, because they are inverses of each other. I like it. So, let me see if you guys really understand what's going on. I know it's always, I mix these two things, an explanation of why things work or where they come from, and then now we're going to do the actual practical stuff here, right? This is what you're going to have to be able to do in your homework on a test. If I said, what's ln of e to the second power? Let's see if everybody understands this. It should be remarkably easy. You don't need your calculators.
The inverse of E.
2.
It's 2, because what did ln and e do to each other? Cancel, because they're inverses. ln is base e, so we know that they're going to cancel each other, and the answer is 2. So then what's e to the ln of 5? 5. Cool. And let me give you a little preview Why was that easy? Because the E and the ln are acting directly on each other, right? There's nothing in the way. So what if I said this? You would, Jeff. What is e to the 5 ln x? What do we always do when there's a coefficient of log in our way? What can we do with that coefficient? It's in the front curly, so I can put it back. Be careful, don't suddenly take it down here. The e doesn't have that property. No exponentializing property. The ln, this log, it can take that back up. Now these two can do what? Cancel. Good. So anytime you see that. So for example, if I had 3 to the 4 log base 3 of w, what do you have to do first? Get that 4 out of the way. So bring it up here, 3 to the log base 3, w4, and then cancel, so that's w4. So just like this is x to the 5th. Cool, all right. Maybe. Because our properties are very specific about what they understand. If it doesn't look the way that my property works on, I've got to rewrite it so it looks that way. Now, real quick, here's, before I forget, it's that age-old problem. What I'm about to show you is a review. Remember the difference here? Do you? Do you remember the difference here? Sometimes I see problems in the homework that make me wonder. But this is the evil thing, but it's not should be any evil anymore. What's the first one?
Negative.
Yeah, because it's, what am I squaring? 2. 2 squared is? With a negative in front. All right, that's negative 4. So people do that in the calculator. They come out and say, my calculator's busted. It's squaring a negative and it comes out negative. No, you're not squaring. If you wanted to square a negative, you'd have to write it like that, right? So if you put in the calculator negative 2 squared, it does the right thing, right? And this is where people come up and they say, I know it's not so well, you just put it in wrong, garbage in, garbage out. All right, so what's this got to do with anything? That one's positive, of course, because I got 2 negatives that make it positive. So what's the difference here? How can I rewrite this? How can I rewrite? Nothing tricky. There's no tricks. How do I rewrite that? What can happen? Yeah, the 2 can come down. Do you see the difference, though, here? It's a major difference. In this problem, what's being squared? X is being squared. In this problem, what's being squared? The whole freaking ln. So this 2 cannot come down. That 2 cannot come down. There is no power on the inside. It's a 1. So take the 1 down. Yay! Take it down again. Yay! Take it down again. Yay! Go insane. But that 2 is just, it's just got 2 ln's. It can't do shit. All right. When you get to, those of you that take pre-calculus, which should be a decent chunk of you, when you start doing trig functions have a very interesting way they took care of this, and you'll see. Just keep that in mind. If you're not going to take pre-calc, then you can let that go. Okay. So that's 14.5. Just make sure you guys remember, how could I do this in my calculator?
Walk base 10.
Yeah, you don't. So how do you do this in your calculator?
Walk base 10.
A lot.
Well,
There's 10, 7.
Yeah, log
11.7.
the bases go on the bottom. Bases on the bottom. Now, to be honest, I don't know if you remember how we did this. We actually just took logs. We wrote the. I don't know if you remember, but it didn't matter what log I picked. Why did I pick log base 10? Because it's on a calculator. What else is on a calculator? ln. And why do you think most math people use ln? I'm going to just do that. I just wanted to warn you. I'm going to default to ln. Because ln has one less letter than log. And we are that lazy. I mean frugal with our time. All right. So I'm just going to default to this. Whenever there's an option, I'm going to default to that because that's my math heritage coming out. Okay, so maybe. How are we doing there? Yes, sir.
We can plug that into the calculator, right? Log base 7 and then.
Yeah, totally.
Okay.
Both ways you come out with the same answer. Are you trying it out just to make sure I'm not full of shit? It's not a bad check. You always want to do it. Is Jeff full of shit check? So if you do this, anybody do this yet? What number do you get? 1 point.
2, 4, 1, 5,
2,
3,
4,
7, 8, 6, 7.
2. Let's stop there. And has anybody done this one?
Same.
Okay, it's incredible. Of course it is. Alright, so that's the change of base formula in case you weren't here last time. The change of base formula in general is that. They're both, or now we know it's that also. Either way.
Fill in and log. Same.
No, they're not. But this is also equal to log base pi of A over log base pi of B, just to make things even more confusing. And let me immediately follow that up with an explanation. Remember, how did we do this? How did we come up with the formula? So if I have this, what is that? What is it equal to? Good, that's a perfect answer. I don't know. So in algebra we call that, when we don't know something, I call it x. So that is equal to x. Try to argue with me. Of course it's equal to x, damn it, because that's what I said. I defined it to be such. But now how can I rewrite this?
B power equal
Now how do I solve this? What do I do both sides to get that x to come back down?
root
Take a log. Any log you want to, because every log has that property, right? But what log am I going to use? Based on what I told you earlier, I'm going to use ln. So when we first did this, we used log base 10. Because we didn't know ln yet. But now I'm going to take the ln of both sides. So what happens? X comes down. Now I'm able to solve for it. Do you see the utility of log? If there's a variable in your power, you cannot solve that equation unless you have the idea of logs. That's the inverse of it. That's the only thing that can bring that variable down. Right? So now I can bring that down. And then I can do what? To get x by itself? Divide by ln b. And look, that is it. There it is. And you see on this step, if you don't like ln, you could have used log. Right? Everyone knows it's log. It rolls downstairs. Anybody understand that? No? We're in instant. I know it's ancient history now. They started it all, and now we're really, really weird. Okay, so that's the change of base formula. You must know it. There's going to be at least one question about it on the test. Just memorize it. It's not difficult to memorize. So let's get a little bit into 14.6, and then we'll probably take a break. Yes?
In 14.5, what if it asks you to graph a function of ln? Like, for example, number 63 in the homework.
Oh, the most important thing about this is the shift, really. So, in fact, this one you don't have to really use shifts. It really doesn't tell you to. There's also the thing about, I almost forgot, is the domain of these things, right? So two things. So what I would do is what makes really good sense to plug in for x. In fact, they got a little picture of a calculator here. So this is where you can just plug stuff in and get decimals. So who really cares? But there is one that I don't need decimals for. Any log of what is always the same thing?
-1 plus.
Yeah, if I plug a -1 in, what's ln of 1?
0.
0. So I can start there. And now you can just plug in, can you plug in -2?
No.
Why not?
You gotta make it 0.
And I can't do ln of 0. What do you raise that to get 0? I can't. And that's because the asymptote's there, right? So what is the domain of ln? ln of x, what's the domain? It looks like this. So what's the domain?
0.
And what do I put on 0? Does it ever get there? Does it ever get to, here's 0, does it ever get there? Hell no. So I put a parenthesis, good. Up to, another way to say this is, whatever x is, it has to be bigger than 0. Just like under a square root, it has to be at least 0. Square roots can handle zeros, ln's can't handle zeros. So what the hell? How do I find this guy's domain? Whatever's on the inside has to do what? Inside has to be greater than 0. So the inside has to be greater than 0. And then you solve. X has got to be greater than -2. So that actually tells you where the asymptote's going to be. The asymptote's going to be at -2. You guys understand? So here, x has got to be greater than 0, which means 0 itself must be where the asymptote is. It's a wall that says, you cannot go here. Thou shalt not pass. Right? I almost bought that shirt to wear for fun. Thou shalt not pass. And then I thought that's a quarter of an evil thing to put out there. Thou shalt not pass. So it can't pass by this, so there's an asymptote here. This asymptote is going to be where? -2. So now at -2 there's an asymptote. So when I plug in -1 and I get 0, right? And now you can plug in whatever and get a decimal. So help me out. If I put a 0 in there, what's ln of 2?
0.69.
Point who to what?
69.
69? So when you do it by hand, you just got to hold it in place. So 0.7. So at 0, it's at 0.7, which is right there, roughly. And then maybe one more. If I put a 1 in there, what's ln of 3?
1.1.
It's going to be 1 point something.
1.1.
1.1? Okay. So that's going to be right there. So then you can see, and this is asymptotic like that. Bam.